Well, thank you. Thank you, everyone. It's my first time to New Orleans, so thank you very much. I appreciate it. It's also my first time giving a talk in a theater, so new experiences all around. So the title of my talk is Rebuilding Espec, Foundations in Metaprogramming. But before we sort of start diving into some of the technical aspects, I just kind of want to warm everyone up and just ask, has anyone tried a dish called kimchi before? Raise your hands, please. Oh, wow, quite a few people. Okay, so in case, for those of you who haven't, they make some great kimchi in LA and Koreatown. I invite you to try the restaurants. That's my tourism plug for Los Angeles. So anyway, the reason I'm telling you that story is because my mom immigrated from Korea. Hence, I have Korean heritage. And when I was a kid, she would sometimes make this dish called kimchi, this spicy pickled cabbage dish. Obviously, quite a few of you are familiar with it. So making kimchi is actually pretty time-consuming to do by today's standards. It's like on the order of days. So it's not like going to McDonald's or Burger King and just sitting through the drive-thru for 5 minutes and getting a burger. So as I was making this talk and thinking about my heritage and how lucky I am, I thought, well, if Mom had built a factory that had made kimchi, she could have saved quite a bit of time. And if she had built a factory that built factories that made kimchi, she would have been meta-making kimchi. So this is sort of the essence of metaprogramming. And I haven't actually shared this insight with my mom yet. I'm waiting till Thanksgiving, so we'll see what she says. Hopefully she doesn't think all that college money was wasted. So anyway, building a factory that builds a factory that does the thing you're trying to do by hand. That's why you often hear of it, the phrase writing code that writes code. So our agenda for today, we're going to talk about 3 things at a high level, BDD, macros and metaprogramming, and then just getting a taste of what it's like to make your own BDD framework like Espec. So this is something I try to do with my, my demo module, my demo test framework that I made as I was going through this talk. It's kind of, I enjoyed doing it, so I hope you guys will enjoy it as well. So before I tell you about the topics, the acronym soup, don't worry, it'll get clear as we go on. I just want to share with you some of my motivations. So I come from a Ruby on Rails background, and so if any of you are familiar with that community, you know there's some meta stuff going on, right? Like, honestly, I often hear people talk about, like, Rails magic and stuff like that. I was just kind of curious about it, so I always was interested in the metaprogramming aspects of that stuff. So I wanted to, like, look at it. When I heard there, it exists in Elixir, I wanted to look at that. And then, of course, the other reason, like many reasons I do things, people that I respected and, actively discouraged me from doing it. So now, of course, you have a rebellion on your hands, right? So for all you Star Wars nuts out there, that's Jyn Erso saying, "This is a rebellion, isn't it? I rebel," from Force Awakens, which is a great movie. Unrelated tangent, but I thought it was a great movie. Those were my motivations. So with that out of the way, let's start diving into the acronyms. So BDD stands for Behavior-Driven Development. And it simply means we want to specify our business behaviors that our code should implement. Typically, this is done through what's known as a DSL, which is another acronym that stands for Domain-Specific Language, a language written to deal with a specific problem domain. And I'm pretty sure I pulled that out of the Cucumber docs or somewhere official online. And to give you sort of a concrete idea, because I think it's easier to explain this stuff with some concrete ideas. So here's an example from RSpec. So RSpec, for those of you who don't have a Ruby background, it's a Ruby BDD testing framework. It served as the inspiration for Espec, the test framework that I was looking at. So here you can kind of see the DSL, so describe subject. It has a name equal to John. We expect that subject's name to be John. You can see the DSL is there. It's also kind of human readable, so that's kind of a nice aspect of it, and I think that's why a lot of people in the Ruby community, liked RSpec for quite a while. Okay, so now you got an idea and an overview of BDD. Let's get an overview of macros and metaprogramming. So I think to understand metaprogramming in Elixir, you first have to understand that the Elixir code is represented internally by an AST, yet another acronym, which just stands for Abstract Syntax Tree. So most languages you've worked with have an AST, but you're typically not aware of it because you're working at a much higher level, right? So when your programs are compiled or interpreted, the source code is transformed into a tree structure. Looks kind of like this diagram above on a screen. And it's before it's turned into bytecode or machine code. And like I said, usually this is hidden from you. One of the interesting things with Elixir is that you can peer into the AST generated by macros by means of something called quoted expressions. So let's look at what that looks like under the hood. So it's a 3-element tuple representation, and it kind of looks something like this. So I have a simple math expression, 4 times 8. You can see the first element in this 3-element tuple is a function call. Now, it could also be like a nested node AST fragment, but in our case, it's just a function call, the multiplication function. The second piece of that tuple there is some metadata about it. So you can see we have an Elixir context importing the kernel module, and then that third element is the list of arguments to our function, in this case 4 and 8. So this quote keyword ends up being a basic building block, so that's why I kind of wanted to just give you a simple representation that can also easily fit on a slide screen as well. Okay, so now you have an overview of quoted expressions. What exactly are these macro things? Maybe let's explain a little bit more. So you've often heard the phrase code that writes code, and part of the reason you heard that is that what a macro does is it literally injects that AST in place of the call during compilation. So your compiled code will have no trace of this macro. It's all gone, substituted by AST that gets returned during the compilation stage. And getting back to quote, I also want to tell you about this other keyword called unquote. So we already know quote takes an expression and converts it into AST without executing that code. Unquote injects values from outside the context. So for those of you who haven't done this before, you can think of it like string interpolation if you're familiar with that concept. And if you're not, don't worry. We're going to do another concrete example. So here in the IEX, I boot up an IEX shell. And I'm, of course, not brave enough to live code, so that's why you have this. This is a representation of an IEX shell. But if you run this code in the IEX shell, it does exactly what it shows here on screen. So we have a quoted expression, another simple math expression, 2 plus n. So we get our 3-element tuple. You'll notice that last argument, it says like 2, comma, and then the atom n and some other stuff. So I'm going to use, to evaluate this in a terminal, I'm just going to use a shortcut eval quoted method. And we would expect, at least I expected when I first did this myself, to get 4. But in fact, if you notice at the bottom of the screen, you get a compile error, an undefined function. It's kind of confusing at first, but that's why I kind of told you about the unquote keyword. So like we said, unquote injects the value into that quoted context. So previously we didn't have it. So if we say 2 plus unquote n, we now have the right context to evaluate it. So if you do call eval quoted on our quoted expression, you get back 4 here, like you would expect, right? I think the other thing that's important to note and kind of keep in mind is this notion of compile time versus runtime. So I made this sort of contrived module just to show this compile versus run. It has a macro called showMessage. And so there are 2 pieces to this macro. You'll notice there's just a put statement right up at the top that says see this value during compile time. You'll also notice there's a quoted expression, and that's the return value of this actual macro that says IO puts see this value at runtime. And because and I'm doing this because in the next slide, what I want to do is hammer home the idea of compile time versus runtime. So what I do is I import that module that contains that show macro into this run module I made. So I call that show message macro with the value understanding it's an atom, and then I start to compile it. So what happens when you compile it? You only see that first puts message. See this value at compile time. So you don't see the other one, right? You don't see what's in the quoted expression, which is actually what we expect because macros are injected at compile time. And if you go and you do the run.start during runtime, you'll see the run start method output. Run start function has been called. See this value at runtime. You'll notice I use some like terminal shortcuts here, Elixir-E and Elixir-C. The same effect can be achieved if you run like IEX mix, which then you'll compile all this stuff, and then you call run.start from the IEX shell. And I'm kind of showing you that just to kind of, I feel like it firms up the idea that the macro is injected at compile time, and it was something I was like playing with as I was kind of researching this talk and you know how metaprogramming is done in Elixir. Okay, so the other thing I also did. I know we're all at the big Elixir conference, so it's obvious we're all passionate programmers and pragmatic programmers, and we care about our careers. So we're looking for these like rules that'll like make us like magically good, right? Like magically like solid, right? Single responsibility, object oriented. Well, this is a functional conference, but you know what I mean. And dry, right? Don't repeat yourself, that sort of thing. So I actually did. I looked around. I was like, oh, there's got to be some rules. I didn't really find any hard and fast rules, but there's some great guidelines, I think, from Sasha Urich, who's kind of an expert Erlanger, and Chris McCord, the creator of the Phoenix framework. And he does some like cool stuff with metaprogramming in the router, I believe. So the first consideration is, does your domain lend itself well to a natural expression by macros? Would making this macro DSL cause the end user to think more or less about how to solve their problem? Obviously, you want your end user to think less about it. And I would argue that a BDD framework is probably the perfect use case because it's kind of abstracted away from your user. You want them to just focus on writing good tests to test their system, right? The third consideration is, can I solve this efficiently at runtime using the usual stuff, right? Modules, functions, protocols, without kind of injecting a bunch of code into the user's context. And I think just from practical experience, having worked on a team and seeing people actually try to do metaprogramming and then introduce it in production, that's sort of a little tongue-in-cheek humor. I think actually there is somewhat of a legitimate healthy fear if you get too carried away with macros. So I mean, just from personal experience, I would say you and your team need to agree when it's a good time. I've seen it used like for validations, simple things like that, and obviously testing frameworks. I guess the other little thing I'll share with you is if you have a C in your title, your team will probably let you write more macros. A little tongue-in-cheek humor there. But everything in moderation, and I think even Chris, or it was Jose or Chris McCord, Josie Bloom or Chris McCord that pointed out, like, doing it too much, you may get programs that are hard to debug and difficult to reason about. So just, you kind of want to, that's why I gave you those guidelines. And there's, like I said, there's no hard and fast rules, but, and I think if your whole team, understands metaprogramming, they'll probably be less afraid of it too. Okay, so let's start rolling into making our own framework. Okay. So here's our example DSL again. It's the functional version, so you'll notice there's a pipe there. I'm calling it Padawan just because I was learning, so that's what I called my little demo module. You could substitute Espec, and it's essentially like the same syntax in DSL. So I described the assertions B module. That's what we're going to build to test this. I give it a context block, and then I finally write the test with it. It checks success, and then we expect 2 to be greater than 1. So it's a fairly simple assertion just to get us rolling. You can build more assertions, and hopefully when I'm done with this talk, you'll have a much better idea of how to do that. So when possible, I also want to say I try to use the Espec authors conventions, even if my use case didn't necessarily warrant it. And the other rule I followed was just to use macros as gratuitously as I could, and it was just really for my own learning. And I'll try to point out those areas as we go through the slides. Okay, so the first little bit is just defining the describe macro. So the first thing to do is just use the defmacro keyword, and that defines your macro with the name and the body. There you see the quoted and unquote block. And then the other thing I want to point out is describe and context. If you looked at them, they basically have the same structure. So I thought, well, I found that, okay, this is a good candidate for dynamic function definition with macros. So that's an example of gratuitously doing macro things. And then so this is what I sort of did. I just created some aliases, a list of aliases. And then in an enum block, I basically started saying, okay, create a macro that's based on this describe macro. I think it's a good time to maybe just share with you my today I learned moment. So, I mean, you can see you avoid adding like boilerplate because, if you try to do it with pattern matching, you can see you might get, a bit more cumbersome in the sense you'd have to like start writing all those specific def handles out. So you'd start repeating yourself. Obviously, it probably comes at the cost of a little bit of readability. I didn't feel too guilty about it because I noticed it's something the Espec author does as well. And so his repo has like 700 stars. So I was like, all right, I'm down with that. And I'm just learning metaprogramming. So yeah, and it was fun to just do actually. And so the other feature that I wanted to tell you about is this bind coded feature, or keyword, I should say. So basically, this passes a binding to the block, ensuring that outside bound variables are unquoted only a single time. In general, I think Jose and or Chris recommend that it's good practice to use it whenever possible so you don't accidentally reevaluate your bindings. So on this slide here, I rewrote that alias with the bind quoted. And then you can see as a side effect, I got rid of a lot of that unquote stuff, right? So it's pretty handy. And the other cool thing that, like, as I was making this, I'm using, well, I use Vim and I use the Ale plugin. So that linter kind of tells you actually if you're, it'll give you some warnings sometimes if you don't have the unquote in the right places too. So that's kind of cool, actually. Okay. So let's kind of dive into building the assertions. All right, so I just want you to keep this diagram in mind as we talk about this. So basically what the Espec author does is he makes this assertions interface contract. So this assertions interface contract contains like 4 methods that you will basically be responsible for providing. So it contains an assert, success, an error message, and a match method. And it's injected into our assertions B module by means of a macro. And I just want you to keep that in mind as we're going through this, because the whole point of that assertion interface is to end up providing a common API for the various assertions like be close to, et cetera. And like I said, the Espec author, it's pretty cool when I saw this. Like, he enforces this common assertion interface by defining an assert method, and then you have to specify when that assertion succeeds. So as you write new assertions in your test framework, you're responsible for the success message, the error message, and then saying, okay, this is how assert succeeds. When match does this, then assert succeeds. And so I just found it to be an interesting like use case of macros as I was trying to like level up and learn how metaprogramming worked in Elixir. Okay, so this is the B assertion module that I talked about. So you notice we're using this use keyword, which we're going to talk about a little bit more later. Suffice it to say, it just injects all that code you saw. And then we're responsible for providing the match implementation and the success and the error message. So in our case, it's a pretty simple thing. I call the apply method to dynamically apply the comparison against the operator. So that subject is 2, that value is 1, and the operator is greater than in our specific test spec that we saw earlier. Okay, and then we just define expect. So expect is like a basic function helper. It returns a tuple, an expect2 module, and the value 2. I'm just kind of telling you this because I'm setting the stage for when we start combining things into the 2 module. And actually, just sort of another, today I learned that when I was like looking at Sasha Yurik's blog, he was saying like a potentially good use case for macros can have them to be, to combine them to like a single place to reduce boilerplate. And so you, like in this case, I could have actually, when I like tested this out, I was just like, oh, well, what happens if I call it a macro? Like it works the same, but I didn't need to do it, so I tried to shy away from doing it in that particular instance. And that was just kind of like a little observation / learning for myself as I was going through this. And the B module, same kind of thing, pretty simple. Pass the operator the value. I return a 2-element tuple containing our assertions B module that we're building, and then the operator and the value. Very similar to the expect helper in terms of the pattern there. Okay, now it starts coming together. So we're about to define our to method. So you can see it's got takes 2 arguments, and I think it's easier to see with this slide because I diagrammed it out. So you remember that our expect function returned that tuple value expect2 with a 2. So that's the first argument, the leftmost argument. And then you remember the B function that was also being, that return value was being passed into the to function. It returns the assertions B module, and then a list of arguments, the greater than and the 1. And then if in the to module, all we do is we apply that assert method that's now a part of the B module thanks to our macro insertion. And then we pass in the subject and the data. So it's literally like just one line because of that interface. So you could see if you have to build another assertion, like you could do something pretty similar to this and it wouldn't be that much much more work. You just have to define your match and your success and your error methods. Okay, so that's sort of like the basics of how it's put together. Let's talk about that using keyword that I said I was going to talk about. So if you notice at the top of the Padawan module, there's this using macro. So basically this allows us to call use Padawan, and it's like provides a common like extension API. You can see the ops there. So sometimes you'll see this passed in the use, whatever module passed in with some ops, so you can do some other things on it. So that's what that's for. And then I also wanted to just point out, because this first looked weird to me when I was doing this. I was like, what? You import an unquoted version of the module itself? But in this case, just remember, in the Padawan module, we had a defmacro describe, a defmacro context, all that stuff that I showed on previous slides. So by doing this, we just don't get an error when we go to implement it. So that's sort of what that's doing at a high level. And with that, let's talk about a Compiletime hook and a module attribute. So we're going to start building our test runner. And basically what that is a mixed task. I just call mix Padawan, and then it runs our tests. But we kind of have to build that piece out a little bit too. And so that's where I'm going to start telling you about this before compile concept. So basically that before compile attribute, it tells the compiler that one extra step is required just before compilation is complete. So it just does like one final bit of code generation, like one last thing. And it comes in handy during our it block expansion, as we'll see shortly. Okay, so this is that macro definition. So we have before compile, so now I have to define what it does. So in this particular case, I'm basically saying we're going to inject this run test method into whatever module that uses Padawan. In this case, that's our bspec module with our test that we showed earlier on. So that's what this is going to do. It's going to allow us to call run tests against this module, and then it'll run all our specs. And speaking of that, if you've been wondering about that at specs, I kind of have to explain that as well. So there's this module.register attribute. And basically what it does is it allows you to store data in the attribute at compile time. So we register the specs module attribute. It allows data to be stored at compile time. And by taking the advantage of this accumulate true option when registering, we keep like an appended list. So if I didn't do it, I actually tested this too on the code. I was like, if you don't do the accumulate, you get like this empty list back, and it ultimately becomes useless. But the next slide, I'm going to kind of show you like the benefit of that, at least for our particular use case. So here's where I define that it macro, and you see the @specs attribute. So it's basically just going to be a list of tuples containing the line number of our test function, and then I call it function ID. It's basically a concatenation of a short UUID along with the description that's contained in the it block, like it check success to, which you'll see on an upcoming slide. And then I basically also declare, okay, now I'm going to dynamically define this function because this is what's going to get tested against our bspec module. And I'll show you talk about that in a little bit upcoming slide. All right, so defining the test runner. So this is kind of where if you remember that run test method, I call test runner.run. So this is where I pass the specs. So the specs are the first argument. This module is the bspec module. So it's that first module that contains that DSL test that I showed you. And all I'm doing is really just saying, okay, call that function that we defined. And then if everything goes according to plan, we'll get back our OK success message. And then in this case, I didn't write like a whole reporting system, but I just wrote, okay, let's write out some stuff, the line number, the test function, and the success message. And of course, taking the advice not to live code anything, if you do this, you'll see, okay, you get the test passes because 2 is greater than 1. You see the description and the concatenation there of the UUID and the test message, and you find, okay, yes, it's true, that's what we expect. And so in that sense, you've built kind of your first test framework, essentially, using macros and metaprogramming. I think the other thing that's kind of cool that I picked up as I was doing this, so there's some introspection tips, things that I learned. So whatever your module is, there's this double underscore info function you can call with a macros atom, and then it will actually tell you all the macros sitting in your module. So like, for example, the Padawan module that we just made, we get all the public macros back with the function arity. So you see our Beforecompile macro that we defined with the double underscore, that's there. The describe with the arity of 2, that's there. The it macro, that's also there. So I think that's actually helpful. And obviously you can do this with any module in Elixir. The other thing that I also found cool was you can pass a functions keyword atom into it, and you'll get back this keyword list of public functions and arities. So you'll notice in the Padawan module, there's really no public functions. There's a private function I made in there in the demo repo, but there's no public functions. But I thought this is kind of interesting to show you guys too. So you notice in our assertions B module that we made, you notice there's an assert module, right? And you remember that came in through the use padawan.assertions.interface module. So that's what I'm saying, like, oh, look, it got injected. Your macro injected that code, right? So I thought that was another way to that kind of drove the point home for me, was when I found this out. And there's some other kind of interesting things actually in the info function. Like I think you can see like some meta information, including like your module's version number. So like it looks like every module, I think it's in Erlang, but by extension, Elixir gets like a version number. So by default, I think. So that's pretty cool. Okay, so to recap a little bit. So macros can obviously be used as a productivity tool to save time and get rid of a bunch of boilerplate. But please use with care and get some buy-in from your team. It's obviously handy for extending Elixir for your needs, as Jose intended. Keep in mind the runtime and compile time environment that you're operating in. Macros are injected at compile time, and it's just helpful to think about your end user. And with that, I'd be remiss if I didn't say thank you to Dockyard for helping to send me here. We're a digital product agency offering custom software, mobile, and web application development consulting. And if you're looking for any of those services, please get in touch with our company. And that's it. I hope you had fun rebuilding this with me. There's a demo repo, so you can check it out as well. That's my Twitter, GitHub, and then a bunch of resources, including the links to actual code where you can just play around with it. And just thank you very much.
Thanks, Bruce. Does anybody have any questions? Does anybody have any stories about, let's see, what's the worst use of macros anybody has done? Do you want to share? Oh, okay, here we go. Here we go.
So, yeah, I'm not going to take ownership for this one, but once upon a time, allegedly, someone may have written a macro to do a bunch of like base level imports, and you had to use that macro for a bunch of different modules inside of the software. So very quickly, you would not understand where something came from, and everything was imported, not aliased. And so, yeah, it was a nightmare to figure out where any function came from. It was horrific. So that's a really bad use of a macro. Don't do that.
Cool. Does anybody have a good case of macros that they want to share? Oh, here we go. Oh, a bad one. Okay.
So this is something that I actually wrote with her, so I'm going to blame it on her. I feel like coming from Ruby, one of the things that I struggle with a lot is like, what is the right way to do code sharing? So you have a lot of modules that need to implement the same functionality. And if I was writing Ruby, I would do like a module or inheritance, but I couldn't and probably still don't know the right way to design like that in Elixir. So we just wrote a bunch of macros to house like shared code, and it just became, exactly as you said earlier, impossible to reason about. Yeah, totally crazy. Not because of me, because of her.
Okay. Anybody else have any interesting stories with macros or test? Oh, okay.
Yeah, so one time I wrote a return statement in Elixir, so you can literally break out of list comprehensions and stuff. But I would highly not recommend it. I literally, basically I wrapped it such that it raises an exception, and then it can like break out of the block. So you can abandon all functional programming if you really want to, but it's good times.
There you go. I think we'll stop right there for right now, but thanks, Bruce.
Thank you.
Thanks.